Whatever's on that screen.
Yep, that's good.
Oh well.
I will probably in 5 minutes have to do the submission because he's not responding. Oh, this might be the magic moment.
Like how many times?
I can focus on my lecture.
He's gonna ask why did you fun? Can you tell him that you forgot you? Good time you fun call you.
So even called you because I couldn't reach you.
Yeah. Okay, good. Alright, let's start.
Okay, go for it.
Hi guys, we will be starting now. So it seems like there are less people today. Nice, yeah. But it's fine because on a bright note, we have a bright side. We have 1 pizza per person today. So yay. Okay. Naman, please.
Hello everyone, can you hear me? I'm going to assume that's a yes.
Yes.
That's a yes. Okay, fantastic. So today's sort of lecture will be on smart contracts, but different to last week, we'll be focusing more on the testing side. The reason this is really, really important is because if you don't test a smart contract and you deploy it on the mainnet, there's a very good chance you will lose your money. Have you guys ever written any like algorithms for trading before, or like written any code before? Generally speaking. Yeah, and like how many times did code work the first time you write it? Like never. It doesn't really happen. It's because like we don't think like computers do. Computers think very much, okay, it's a variable, we change it, and the variable updates in our score, but we might make an assumption about what we think is in a certain variable at a time. And the problem with this is that the code won't work, you'll lose lots of money, and you're probably going to wish that you never started this course in the first place, right? So how do we get around that? Well, we write tests. And there's lots of different types of tests we can write. There's unit tests, there's integration tests. And we'll look into writing unit tests today for Rust, and then look at some examples of integration tests. When you're a computer scientist, like Robert Chadwick teaches you this. When you're not a computer scientist, now Java teaches this. So let's get into it. I have a place for you guys to code today. We're going to be using the accounting contract on the Near blockchain example. Screen frozen. Screen's frozen.
Hang on.
So this laptop's like 5 years old. It's getting a bit old, but
That's good.
that's not great.
Yeah, that's not great. Restart?
Yeah, let's do it. Let's do it.
Where is it?
Sorry about this. In the meantime, if you want to keep yourselves busy, you could type out this whole URL into your browsers, and then you can go along with me. Otherwise, I will. Nice.
Very good.
I will generate a short link. This is the URL. Can you guys see it up here? If not, I'm going to generate a short URL that you can try. The reason I haven't done this before is because I wasn't sure if it's going to work, but I'm 90% sure it will work this week. So you guys can just type this URL into your browsers, the shortened one, and let me know if it works. Sure. And whoever's got like the fastest typing would tell me that it doesn't work, or it does work. This will assume a little bit of knowledge from last week.
It works. It works.
It works?
Yeah.
Nice. I'll wait for everyone to get ready. Like, put your hand up if you're not ready. Otherwise, I'm going to assume you are ready. Nice.
At least they're honest.
Yeah. if it does work and you have managed to copy this down, you should see something like this thing. We'll go through the project structure again. Sorry about that. I'm muted. Okay. Any hands still up? Okay, it's fine. Take your time. I'm not in a rush. I think I could probably like start talking to the next part whilst the rest of you are getting ready. Is it just a few people here who haven't managed to get working? I'm going to assume yes. So the concept I taught you about, well, I will teach you about something called test-driven development. So just for context, this is what we're expecting to use. We're meant to use this counter, this thing here. And what's going to happen is you're going to press that plus button. The value which is stored on the blockchain will go up. Then you press plus, minus will go down. RS is reset. RE is blinking that eye. LE is blinking that eye. L is just something I don't know what it does. So first question is, what do you expect your contract would need, like to store a variable? Like you need a struct, right? Some sort of state. What tests would you think of writing to make sure that you are okay with incrementing, decrementing, and resetting? That's what RS is, resetting to 0. Have a think. If you can't think of any tests, I'll give you some hints. But like one test, for example, would be, does it increment correctly, right? When I call the increment function on my contract, does the variable that's stored in the state itself actually increment? That's an idea for a test. Another idea would be, does it decrement? Another idea would be, does it reset? So I come up with these 3 ideas for tests. Can it be incremented? Can it be decremented? And can it be reset? So can you guys go to this sort of librs? So if you go to source, which is in contract, you can see librs. So libcomplete is what you will be doing by the end of this lesson, but librs is something I've written for you, which is commented a bit more. And this is what we'll be working from today. I'm going a bit more slowly this week, so you guys can code along. I think that was some feedback we got from last week, was we were going too fast or you were not able to code along. Let's look through the code and see what I want you to implement for me today. So we have this struct for our counter already. This is storing, does anyone know what this means? Like val i8. Eight bytes. So what was I going to say? So we have this counter, and then we have this implementation for our counter, and it's going to have our 3 methods: increment, decrement, and reset. So what you do, the first thing you do when you write any smart contract code, you define like the stub, which is what I've done here, which is just the very basics, and you hop straight downstairs and you write some tests, right? Here are my tests, and we can see what happens if I run these tests. So you can try running these tests yourself. The way to do this is just go here and type in cargo. Open a new terminal, actually. Type in cargo test. See daisy. So to figure out what to type into the terminal, you can go to something called the package JSON, which has all the scripts we can use. and we want to do this one. So you can see the mistake I made was I didn't cd into the contract directory. I can cd into the contract directory and run cargo test. So you guys can try doing this right now. Run cargo test. It wasn't meant to happen. Wait, cool. And you'll see we have 3 test failures: decrement, increment, and counter, increment, and reset. So all of our tests have failed. Why do you think this is? If I look at my tests, this is the code for the tests. Can you guys guess why that is and why the test's failing? Well, exactly, right? Like we haven't written any tests. So should we start by writing some tests? Does anyone have any idea of how we can write a test? For example, increment. Yeah, so what would it look like? Do you want to come and type it here? I'm trying to zoom in. How do I make my sort of writing bigger? No. Yeah, go for it. So you can try it. And you guys can also at the same time try to write a test for the increment. And remember, this increment works in this counter, which is for this struct, and it has to increment our value by 1. So try to write this test. If you have no idea, that's fine. Nick will do it for you. Sure. I did so. Is it? Yeah, it's like a show. Where's don't type 5? Okay, perfect. So admiration is fine. I guess. This is perfect. This is Nicholas. Whatever you do, these guys can see. So
nice.
Try it out.
Okay, so we've got struct.
Well, I'd say one thing. Just pause. If you guys don't want to see this, what I recommend is I'll send you a link, and you can copy and paste the code in this and write it yourself. Like, would you prefer that we all code together? Because that was like a preference from last week. Or would you prefer to code yourself? We have a antithesis there.
You can just give the link, then those want to code themselves.
I'll send you guys a link so you can code it yourself. And you can copy this page. Give me 1 second. You stay here.
Yeah.
Just let me see. So to get that link, we can go to the near documentation. You can just follow me guys here. So you go to near docs. And we can do something called counter near. And this is the link we need. I'll do a little shortened thing for it as well. So for those who want to code separately, i.e. this one person here and anyone else, you can use this link. And for those who want to code together, you can stick to the previous link. I recommend like do what you want. So anyone who hasn't been able to copy this link, just raise your hand up. Is that a question? Where are we? Oh, okay. Contract source. This is what we're looking at. Are you on the share one? Or are you on the? I think you're on the share one. But you'll start. Has everyone managed to copy this down? Perfect. So we can hop back to
The share one.
yeah, which is here. Oh, which is not here. Which is here. Oh, a lot of highs. Perfect. Nick, do you want to take it away again?
Yeah, sure. Okay, so we've got our counter struct here.
Yeah.
I'm assuming this macro is in the prelude, so I don't need to import it or include it.
No, you need to.
So this brings the counter struct into this module, the test module, right? So we're going to be able to access it from this module.
Yeah, go for it.
So we're going to
You can get the micro compiler, please.
let's just instantiate a new strike counter,
Yeah,
which is value of we can start with
this is pretty much
is it val 0 like this.
Yeah.
Yeah, so start.
Really? Did anyone else get a virus? Everyone starts from below. I'm gonna take care of that. Was that just hers or did anyone else also get a virus? Do you have an sorry. I'm not liable for any viruses. I'm gonna make that very clear right now.
Like, no, she messed up URL. It was a malicious URL that was mapped to.
Yeah, that happens.
Because when I first typed it, I mistyped it, and I ended up on a Discord thing.
Oh shit. It's case sensitive, right?
Yeah, because I didn't put in capital letters.
I did not put any viruses in these links. Like you saw me generate them right now. This is the reason I generate these links right now. This is recording, so I have all proof that I generated the links right now. Not viable for anything. I think this counter might not work because it's unmutable. You have to make it mutable. Yeah, you should be fine for the rest of it. You can write some assert equals. We'll just wait for her virus to get fixed. You think is the virus serious?
Not URL virus. Nothing to do.
Oh, perfect. I did. Should we continue and then your virus can be sorted out by Yufeng if that's fine. So
Okay.
Nicholas, can you finish off writing this our test case? Did you have finished writing off?
Hmm?
You have finished writing the test off?
Yeah, okay. So yeah, let's just so we have, or should we like store val in a, yeah, no, let's just go. So we have 0 as the initial value for counter.
Yeah.
If we just try to increment our counter, so
That looks fine. Yeah, looks good.
Yeah. So like if our counter works, the value inside the counter should now be 1. So we can verify that with an assert
Nice.
macro.
Use the one. Yeah, nice.
Assert equal it's macro, so we have to this
Very
thing.
nice.
So we're going to put expected value first, right?
Yeah.
Don't know. So yeah, the increment function is supposed to increment. So yeah, value should be 1. And our actual value is going to be counter. Oh, right. Yeah.
Actually, let's implement a function to see the value. So if you
Okay.
scroll up, you might see there's another function that's commented out currently.
Yeah.
Get num. So we generally want to use getters and setters to access the variable values in our struct, rather than just using dot, because that's not very good practice. So you can maybe use the counter dot
Okay, so you want to use the
to get num. Yeah, that's it.
like a get or something. No, I thought okay.
Yeah, looks good.
And
what do you think is the next thing to do? Just try cargo test, or do you think it looks okay? Like,
well, I don't know. Is this gonna like this is different test function?
yeah,
so.
but I think you'll see in the bottom like the different tests will have different sort of error messages, so you can try out and see what happens.
I know we can try cargo test in the worst case.
Okay.
Okay.
So a bunch of
yeah.
like, errors,
I
which
need
makes
to
sense because
comment.
this is commented out. The reason it's commented out is because if I left it in, it would return an error because it's meant to return something, but I can't leave an empty stub in. So you're gonna go ahead and implement that.
Yeah, sure.
Nice.
Okay.
So one thing that this needs to take arguments as a function. This function, even though it's implemented the counter, it has to take arguments to know which counter it's getting the value of. So it'd be good to set up the, yeah, exactly.
Yeah, it's like a member function. So we're just gonna return.
One thing I would say is here, Nicholas did a really good thing. He hasn't said it's a mutable self. He just said it's self, which is good because it's just a getter. It's not changing the variable's value. And you want to prevent accessibility issues. So you want to prevent giving anyone access to change the variable where they shouldn't be changing it, and they shouldn't be changing it in get num. You only change it in a mute, like an increment, decrement, reset. That's why this is really, really good. Like otherwise you might see in reset we have a mute here. And this is because we're actually changing the value. But up there we're not, so we shouldn't put the mute in. And it's really important to not expose like mutable accessibility where it shouldn't be exposed. Thank you.
Yeah, self is basically access this, right?
Yeah.
Okay. Yeah, let's try that again.
Oh, this is green. So
Okay.
there's a different error now. Yeah, that's good. Like, I think the error is saying basically increment isn't doing its job, which is fine because we wrote the test assuming it would do its job, but it isn't doing its job. So now we can go ahead and implement increment.
Okay. Yeah, so this is the implementation for counter. We need to pass in the self, like we need to modify the struct basically. So as we need to modify it, we need to pass it as a mutable reference.
Exactly.
So we're gonna
following this syntax here.
put that in the parentheses.
I use copy and paste from like
Um,
exactly. And now like the expected behavior is to increment it by 1, right?
Yeah.
That's why we have this log message. So we can change the log message after we've done the 2D. Yeah. And then one thing I do is change the log message. Is it good to have log messages because it's easy to debug which part of your code is working, which part isn't? But I change it from a 2D to just increment counter by 1, and I might even put like I might change it so it shows the value. Do you know how to do it?
Yeah.
This says like count has been incremented by 1. Current value is equal to. Yep. Pick this up now. Nice. Or maybe you can even call get num. I think it's fine.
Yeah, is this gonna borrow the, no, it's
I think it's fine to do well. We get them to go there. Cool. So if I running this.
Okay, yeah. So this is because now
yeah, so this is probably you have to do this beautiful.
Yeah. So now this function is I'm gonna modify the counter value here. But like this function is gonna modify the counter value, so I have to declare it as mutable.
So just to explain why we do this, the way Rust generally works is the compiler is more restricted than normal. And by that, I mean, it doesn't let you do stuff that you'd be okay in other languages, like accessing variables or accessing struct. The reason is if Rust's compiler can be more strict, it allows Rust to be more sure that the code you've written does not have any errors when it comes to runtime, like memory leaks or thread safety issues. That's why we have to be more and more strict when it comes to coding in Rust and adding these extra mute keywords, borrowing references, and so on.
What's the difference between about?
No, let is to declare a variable. This is just like how we called.
Values of the
Yeah.
name. You can change that to
Yeah.
I meant something.
No,
Yeah, okay.
We can change that. That's the name of the variable we give.
I can change it to I don't
Value,
know.
whatever you want to do.
So let is immutable by default.
Yeah. And that's probably a better thing, right, than having it mutable by default, because you're more likely to put lets in and forget the mute in than put let in and remember to put not mute in. If that
There's
makes
no
sense.
distinction between it. So there's no like different syntax between constants and bursts.
You not really just use let and then you can create like we have done here. I mean, mutes allow you to change it. We should think of it more like everything can be considered a variable, but most variables are read only, and then some are write to as well, and that makes it write to. So I think more than read only and write to versus variable constant sort of ideas. Yeah.
Yeah, no, I don't know if it's like similar, but like in JavaScript, you use const most of the time, and like when the variable has to change, you would less. But like most of the time, it's just const.
Yes, like exactly. You don't want to be creating the scope for things to change because that makes it more likely for a contract to fail. Like essentially, you give minimum control to the person using the contract and retain most control for yourself. So yeah, I mean, do you try Cargo test again?
Yeah. Okay.
Okay, you just comment this log out. It might take a while.
Yeah.
Normally it's to like add logs in, but because I don't want to like spend too much time, it's a few more things I'll talk about. We'll just comment it out. Okay, so you might see one test passed, two failed. So that's a good thing. And if we scroll up, we can see which test has passed. Increment, okay? This is good. This means our contract's working now. We're doing the very basic functionality. Thanks so much, Nick. There's, I guess decrement's very similar. I can sort of write that quickly myself. Let's see what the slides say. So this is what we've done for decrement. This is the code we're expecting to see. Can you all see that? Do you all want to like sort of copy that down? I'll let one of you guys copy it down into the area I'm working in. I want to talk about some other stuff that we expect to see afterwards. So this is a test behavior. You can copy this down freely. When you run the test, you find it all fail because you haven't implemented the decrement and reset. So I'll give you guys an extra 5 minutes to copy this down and implement the functions around this. And let me know like if you haven't managed to get it going. I think key things here. Yeah, this looks fine. I mean, does anyone have any questions about the code here for the decrement and increment and reset? This can equally be decrement and reset. Like, these are all possibilities.
Yeah, just a question, why do we need exclamation mark after certain equals?
Because it's a macro. So think of a macro as like a chunk of code someone else has already written, and you're going to insert that and write this piece right here. And the reason we do this is because if I wanted to do exactly an insert equal in Rust, the amount of code I've been writing would be so long for this one line. I kind of want to put that code somewhere else and just shorthand reference it using this insert equals. It's a very similar concept like C macro as well. You can put it in C equal. Have you guys managed to copy this test down? Let's have a look at see if anyone's done it on mine.
Refresh it.
Oh, nice. Someone's been very helpful for me. I run cargo test. Not compiling. Oh, because I think must be a minus. Oh, it has got this part. Okay, increment reset is failing, that's fine. Decrement's passed. We look into why this is failing maybe later on. Yeah, that's exactly what we'll get to that. I think it's good to see if they recognize. Yeah. Has everyone managed to write some sort of functionality for this? Are you all with the test done? I'm assuming silence means yes. And anything else we need to know? So based on what I've seen, like this is what our code is. And if I run this again, this was a 1 before. Let's fix that to 1. We were having this error, which was like 2 tests are passing, but 1 test is failing. And this is why we write tests, because tests are a way for us to check that what we write in the code makes sense to us. And then we look at this. Why is this test failing? So we look at the test and we see, well, I'm resetting, and resetting involves going to 0, but I'm checking against 1. So this tells me my test itself is wrong. And that's something people should consider when they write code, is that often the tests have been written by someone who's human, and humans make mistakes, right? So if your tests are failing and you've spent ages debugging and you're not sure why your tests are failing, maybe look at the test. The test itself could be wrong. And that's the case here. Because when I looked at my code, I was like, this looks okay, right? So it must have been the error in the test. And this should be 0. So we've got through some of the basic tests, right? When I talk about counter, I'm talking about increment, decrement, and reset. Does anyone have any other ideas of tests we could implement? Like,
We have 0 and we try to decrement. We don't want to decrement
why is that?
because we cannot have negative numbers.
Why is that?
Because we have
If we look at our code, like, do we ever say we can't have negative numbers? I haven't said anything's unsigned. I've said, so just to clarify, when I asked you guys earlier on what I8 means, it's an integer, right? But there's 2 types of integers in most programming languages, like in most computers. There's unsigned and signed integer, right? So unsigned means it can be, as you say, only positive, including 0. This is not unsigned, this is signed, so we can have negative numbers. Now, you can have test functionality to not allow negative numbers, but then that has to involve some sort of like if statements or catches within the decrement. But we don't mind that right now.
Or signed numbers, there's a max and min.
Yeah, I mean for any integer, right?
So you will want to make the max
Exactly.
signed at 128. It was
Yeah.
Today's
What? So you're completely right? So let's just say that again a bit louder for the recording and anyone else. We've implemented a variable called val, which we change the name of it, but still val here. And this is what we're using to increment and decrement and store the state. But it has an inherent limitation. It's only 8 bits, as we said, right? So 8 bits means you can only store 2 to the 8 numbers. And because this is unsigned, this is signed, that means you can go from minus 128 inclusive to 127 inclusive. And what can happen is if someone spams that counter button and makes the number go really, really big, you can get like a 129. But I can't store that. What's going to happen is going to sort of recycle to like minus 127. You don't want that functionality, right? We want to make sure that this counter value stays between our upper and lower bound. And this is really important because lots of people don't think about these errors. And these errors are called overflow and underflow errors. And it just tells you how important it is to write a good test set or test data set. We want to make sure that we are like checking for these. And the way we can check for this is putting a panic here. Like see this macro here, this inherent thing that should panic. And what happens if we try to decrement on our smallest possible number, we'll have an issue, we have a panic issue. So I'd say one thing, can you guys like add these 2 tests to our testing suite, which is ensuring that we can't have underflow and overflow. It takes 2 minutes to do this, but this is a really important concept. And like this tells you that when you think your contract is complete, it's not complete because you haven't thought about the edge cases. And this is why we write good tests, because we want to consider everything. And when it comes to any financial software, like if you apply to any sort of trading company, they'll always make you think about edge cases and they always make you think about writing testing suites, because fundamentally an error like this can be the difference between losing nothing and losing £1 billion, right? So that's the reason we want to make sure we are very, very secure in our head what the value of our state is. Let me know if anyone hasn't yet implemented these tests for underflow and overflow. Or if anyone has any questions as well, please feel free. Like, there's not enough of us, so you can just shout out. So I'm guessing people have done it. So let's look at the state of our contract now. Okay, so we can just uncomment this. So if you look at our contract now, this is what we've written. If you run cargo test, we'll see that it passes every single test, which is really good. It means it does what we think it does. And this is a process you should go. Sorry. Yeah, exactly. Yeah, but then you have to put like if statements around it, right? And it's just a bit easier for your code to read like this because it's entirely cleaner. Like when you have one should panic, and you want to like whenever you're writing contracts or anything that can get very big as a code base, you want to minimize if statements and all this sort of waffle because you can keep that very out of it by just having the should panic, as you said. We can. You can do a log. You can check a login like this, or you can put a panic in. Like it's up to you how you want to do this. I would recommend putting a login, like a log this error message, rather than a panic, because we have then like overlapping panics. Does that make sense? Okay, so that's like the contract of this week done. It's pretty basic, but now you know the process by which you should be writing contracts, which is write a test, write the sub function for that test, pass that test, and then write another test, and keep on doing this. So always write contracts in a test-driven development way. Test first, then the code. And there's a big reminder, as I say, is just run cargo test frequently. Just like every time you write a line of code, run cargo test. It's like the source of truth. It's the compiler. It's the best thing you have because it tells you when your code is working well or when it's not working well. You remember the differences between mutable values and immutable values? Or like, can I change something? Can I not change something? Do I expect something to change or do I expect something not to change? And lastly, when you have errors, the most useful thing is to have a log, like log the output, because you can never be sure what the computer's thinking unless you ask the computer to tell you what it's thinking. We aren't computers, we can't read your mind. It's like if you're in any interview or any sort of scenario where you're confused, tell someone you're confused because I can't read your mind if you are confused, right? So that's it. That's our contract. Now, for the last 10 or so minutes, I'm going to look at the rest of the code around the contract, right? Which what is considered our sort of front end and the integration tests. So I'm going to just go straight from the repo. So here we are. Here's our repo. I'll be quite quick at this part because this isn't the focus of our lecture that much. We can deploy this. So if you go to the package.json, you can see how to deploy it. Go to CD contract and run this script here. So I can do something like npm deploy. Npm run deploy this one. And what this is going to do is deploy our contract. And you can see for this account, which is like my account, it's deployed it to this node from this sort of WebAssembly file. And it says done deploying. So now we've deployed our contract. Should we see what it looks like? So we can find out what it looks like if we just hop over to our first terminal we had. Oh, maybe not. We should do something like npm start. So here it is. Here's our sort of front end for our application. You can see I'm already signed in, and sure enough, it increments and decrements. Now it will take some time because when you're incrementing this variable, it's actually stored in a contract. So you have to approve a transaction, which is like saying I'm allowing this to be incremented. So let's do that. Let's approve this. And you can see this contract value is now 1, and so on. I can increment it. It takes some time because it has to actually update the physical contract on the testnet, and each update might take a transaction. And you can see literally what's happening. You can see this contract, which is probably the same as the number I had here. Let's scroll up. Maybe I can find a different thing. But what's happening on this contract, we're calling this function, right? With no arguments. And you can really nicely see what the transaction is being pushed onto the blockchain as is being. And then once again, I can approve it. And once I've done approving it, I will see that my front end will correspondingly update to show the 2. And I can look at my sort of my front end fun features, which I close the eyes and open the eyes. I can do the reset and see if this works. And it's probably going to ask me once again to approve. I think there's a way to stop this happening. I thought this code implemented it before, but apparently not. So now we can see that actually our contract integrating quite nicely with our front end.
So there's a way to stop it happening. Is that just for the test network?
I'm not sure. I've actually deployed to the real net, but I guess as a developer, there's probably a way to like, when you have that message that pops up saying give permission, you can probably say ask permission for multiple transactions. And I think here, if I look at the contract, it's only asking for permissions for one transaction, which is why I'm getting lots of these requests. When you're a user, as a developer, you want to you want to retain your user's trust. If I ask the user, can I see your wallet? Can I see your past transactions? Can I see everything? As a user, I'm less open to allowing this to be seen. But that's why it's really important to minimize the amount of data you take from a user and consider that in your sort of contract planning journey. Here, I'm getting annoyed that I have to keep on pressing approve, but it's fine because I'm not really accessing any private details. But if I was making a £1 million transaction, I'm very happy to press approve each time, right? So that's how our app looks and works. Should we look at the integration tests? So if you go to integration tests and click source, you can see this TypeScript file. And this is actually a bunch of tests that we write to make sure that front end correctly calls our back end. So unit tests test the contract, but the contract is something that is not accessible without a front end. So integration tests check if the front end correctly calls the contract's functions. So the way it does this is you write a bunch of tests. You can ignore this function here. This is like some sort of like prerequisites. Then you have, as we expected, 3 main tests. Can I increment? Can I decrement? Can I reset? The difference this time is this is actually happening on my front end. And I'm testing to make sure that my front end is calling my back end. Okay. And the reason we have some awaits and asyncs is like a lot of the stuff we do when it comes to the front end is not sequential, right? I have to wait for the user to click permissions granted for the contract, click approve, and so on. And the way I tell my code to wait in TypeScript is to use await keywords with an async block. That's why you see lots of awaits. Does that make sense? Do you want to have a look at this sort of integration test and ask me any questions you might have, rather than me walking through each line? So take, for example, this contract, like decrement. Look through it line by line and let me know if there's anything you don't understand. Here, Alice is like the contract's name. Or the counter's name. I'm guessing that makes sense. There's a last part of this sort of today's lesson is looking at the front end code just to make sure we understand how that works. So let's go to the front end. Let's hop over to this index.js. Let me know when you can see the index.js. The index.js is responsible for actually calling the functions on our contract. And as before, we'll see lots of this like sign into the contract code here. And like whenever you guys are writing your own smart contracts, just copy and paste this code, right? Because there's no point in writing the same stuff again. Like, yes, you might feel very productive if you write lots of lines of code, but you can copy and paste lines of code and that's the productivity, but more in less time. And then we have probably the main parts, which are these call methods once again, where we can call methods on our contract given certain presses of items on the front end. For example, increment, decrement, and sort of reset. And we can see if we're getting the number correctly, because you might wonder, why do we have this getNum function? Well, the reason we have this getNum function is to show the number of the contract on the sort of the page of the person. To be honest, I don't have much more to talk about. If you have any questions, feel free to ask. If not, there's lots of pieces at the back which I can help, or Imran can help distribute. Thank you for listening. That's it.
actually need repaying it to yourself in this case.
This, see, I'm not actually paying anything to my wallet here. What's happening is the transaction fee, so to make sure that the blockchain can have the latest states. And that actually costs money as well. Whenever you update the blockchain, you have to pay a transaction fee. Because that's how they can show that what you're sending as a request to the blockchain is legitimate, rather than someone just spamming it with fake transactions. So by